So let's use that parallel lines theorem. So in the diagram, angles 1, 2, and 3 are congruent. GF, which you can see here, is 120. DE is 150. And CD is 300. Find the distance HF, which is this, between Main Street and South Street. So something we want to note is that if angle 1 is congruent to angle 2 is congruent to angle 3, what's the relationship between those angles if you consider these Main Street, 2nd Street, and South Main Street? If angle 1 and angle 2 and angle 3 are congruent, then those three lines are parallel. And does anybody remember what theorem or converse is? That would be the corresponding angles converse. So you know that those are parallel. So what can we do? Well, there are kind of two ways we could look at this. One way would be to solve for GH first and then add those together. So you could do maybe 120 over GH would be equal to 150 over 300. You can reduce these. I don't tend to. I tend to kind of just jump right in. So cross multiply, you get 150 times GH. Zoom in a little bit. 150 times GH equals 120 times 300 is 36,000. Divide by 150, GH is 240. And then you would get HF by adding 240 and 120. And that's in yards. The other way this could have been done without the addition at the end was if you solved for HF right away. So let's say HF over GF would be that 120 would equal, well, the proportional piece to HF would be CE, which would be that 300 plus 150 is 450. So that'd be 450 over 150. And when you do that cross multiplication, you get 150 HF equals 54,000. When you divide by 150, you get 360. So that's just another way to do it, depending on if you want to do some addition at the end or not. Either way is correct. All right, and the last theorem of the day, no proofs today, very exciting stuff, is the triangle angle bisector theorem. So it has to do when you bisect an angle of a triangle, which means we're cutting it into two equal pieces. So if a ray bisects an angle of a triangle, then it divides the opposite side now. So it's the opposite side to the angle is the side that doesn't touch it. So the side opposite angle C would be AB. So if a ray bisects the angle of a triangle, then it divides the opposite side into segments that are proportional to the adjacent sides. So this one's a little tricky. You want to pay attention. So here, if CD bisects angle ACB, then what? Well, what it means by it's proportional to the adjacent side. So if you had AD and BD, those are proportional to these adjacent sides, AC and BC. So there are two ways we could set those up. So yellow over yellow equals pink over pink. So AD over AC equals BD over BC. Or you could think yellow over pink equals yellow over pink. AD over BD equals AC over BC. So that one is a little tricky. You want to make sure you're not combining sides when you're working through that.